Okay, saya dah record dah session ni, right? So I'll give you the authority to to do whatever you like. So I'll give you 5 minutes only, and then I will continue with the lecture, right? Nak tulis apa pun, nak tulis test ke apa kat situ ke, semua boleh. Yes, Muhammad Azamun. Let me see your face. Who else want to show his face? Dia nak test apa ni, tablet. Good. Right, segan apa ni, Muhammad dah. Saya letak bawah ni. So saya letak balik atas. Okay.
Right, sir.
Okay. I'm going to start my lecture now. I'm going to remove the authority now, right? So the authority that I give it to you. So we have is laminar and turbulent flow. So I'm going to directly person that give lot of significant contribution to the fluid mechanics study, right? Some experiment there, right? So we have like a tank, water tank, and then you put some dye, a dye here, and it allow the dye to flow along the water, and then we have a part there as an exit so that the water can flow. And this is the schematics of the experiment. So we have this dye in the container, the inlet of the exit of the tube or the valve that we install at the downstream of the pipe is open, right? So the dye will flow along the pipe, right? So this is showing you the it's not really a vector because normally a vector is a straight line, but this one may be showing you the kind of representation that this is the path of the water particles, right? So we have a symbol there, Q, to represent the volume flow rate. I don't want to confuse with the thermodynamics where Q is a rate of heat transfer, and then we have a capital V there represent the velocity in the axial direction, and A is the cross-sectional areas. D is the diameters, right? So here, he is using a smooth pipe. So these are the geometrical properties of the tube. So the entrance has a well-rounded entrance. These things will contribute to the energy losses in the pipe. As I mentioned earlier, we have the laminar flow and turbulent flow. Laminar flow, you can see the of the dye, so it does not break on the flow, right? This at the slower speed. As we increase the speed of the water by opening the valve, right? So the flow become turbulent. So we have the laminar flow first, and then we have the transition region, and then the fluid become fully turbulent. So this turbulence nature can be we can make it faster by introducing various factors. For example, in this case, the late Osborne Reynolds using this electric spark, maybe to introduce a body forces inside the flow so that it can accelerate the turbulence transition. Now, so we're going to look at the actual distribution of the flow when the flow is laminar. This is a cross section along the pipe. So we have coordinate system that we uh, assign to this diagram, right? So along the axis of the pipe, location of this X is at the center line of the pipe. Axis there represented by R, right? R is the radial locations, and the origin of this radial location is at the center line. So we consider a point here, and this point is moving um, uh, with the fluid. So this one will be a fixed uh, initial frame of reference or initial coordinate system. Not moving, but it's a fixed coordinate system. So if you recall back on dynamics for velocity vectors, the origin of the vector is placed um, on the particles, right? So here we place a control volume at this location, and then we just plot the magnitude of the vectors, and then we, after we have plot all the vectors there, and then we are connecting all the tips of the arrow, and that will give you the velocity profile. So in this case, the velocity distribution, which is V, is written as the um, local uh, velocity of the fluid. So I just interchangeably using U and V there, right? So earlier notes I'm using V, so they are same, um, and the unit will be meter per second. So it's just a symbol, right? Doesn't mean anything here. It just so I just say that this one is an in X direction. In the earlier videos, one of the property that you have to, right, so V will be the local velocity of the fluid at that particular, at any particular radial location, right? So when we say that the local velocity varies with radial location, D is the diameter of the pipe, and always using the unit meter during the calculation. What we're going to do today is to give you a quiz when the velocity is based on the actual distribution of the flow, right? So this will be your quiz that you have to submit tonight along with the quiz 1A, right? So in the earlier lecture, I give you a quiz 1A, right? So you have to submit that with this quiz 1B. So Quiz1b here is to need to calculate time rate of volume flow and mass flow when the pressure difference let's say 2 Pascal along 2-meter pipe, right? So that will be the quiz 1b. You have to calculate the time rate of volume flow and mass flow, or you can say that I need you to calculate the volume flow rate and mass flow rate for water, right? When the pressure drop is 2 Pascal along a 2-meter pipe. So the velocity distribution is given by this equation. So I forgot to mention about the diameter of the pipe, right? Say the diameter 2 meters, 50 mm diameter pipe.
Sir, isn't that this class is first class? Our host lecturer.
Sorry?
This class is first class, sir.
Yes, I know.
But sir said the 1B is for second class, isn't it?
No,
The
you have two
question.
quiz. You have two quiz. One is quiz 1A. If you um, watch the video YouTube playlist, I'll give it to you. So there is a
Yeah.
quiz, and in the description I say that the student in section 2 have to submit the quiz 1A as well. So when I'm
Okay, sir.
yeah, it's not very typical quiz actually.
So the 1A and 1B is have to submit in by today, sir.
Yes, 12 o'clock
Okay.
at night. Right, so let me remind again the submission file name. This is a convention that I use in all the document. So this one will be quiz section 2, right? So you are section 2 underscore quiz 1b, right? And then your student ID, let's say Najmuddin FB190 33, and then you can send by PDF file, right? And don't submit PDF file on my phone. I have a small storage memory phone, and I want you to send from Dropbox link, right? So using a Dropbox link, and you have to download the Dropbox, right? You have to download Dropbox for desktop. Um, Please the file there, your transcript or your scanned document there in the Dropbox folders, and then you can copy link the file and then just send the link directly to me, right? Okay, now